In this video, I am going to discuss about parameters in resistance welding process. The principle of resistance welding is the Joule heating law, where heat Q is generated depending on three basic factors as expressed below. Q is equal to I square RT, where I current passing through the metal, R resistance of the base metal, T duration time of the current flow. So in the resistance welding process, the heat produced during welding process Q is equal to I square RT. So the heat produced depend upon current passing through the metal, resistance of the base metal, duration or time of current flow. So the heat is directly proportional to, heat Q is directly proportional to current, resistance and duration time. So parameters in resistance welding process. There are mainly 6 parameters in resistance welding process: welding current, welding time, welding force, contact resistance, material property. Last one is geometry and dimension. So I will discuss one by one what are the important points regarding each parameters. So first one is welding current. See, the heat generation is directly proportional to the welding current. As per this equation, Q is equal to I square RT. The heat generation during resistance welding process is directly proportional to the welding current. See, the welding current is the most important parameter in resistance welding, which determines the heat generation by a power of square. The size of the weld nugget increases rapidly with the increasing welding current. But too high current will result in explosion and electrode deterioration. That's the important point. The size of the weld nugget increases rapidly with the increasing current. So welding current increasing അനുസരിച്ചിട്ട് welding nugget size increasing. But too high welding current result in explosion and electrode deterioration. So in this way, the welding current that will affect the resistance welding process. Second parameter is welding time. The heat generation is directly proportional to welding time. As per this equation, Q is equal to I square RT. The heat generation during resistance welding process is directly proportional to welding time. See, if the welding current is too low, it will increase the welding time and will not produce a good weld. When the welding current is too low during the resistance welding process, the welding time will be increasing and it will not produce a good weld. When the welding current is too high, the size of the weld nugget increases with increasing welding time until it reaches a size similar to the electrode tip contact area. See, when the welding current is high, the size of the weld nugget will increase gradually with welding time until it reaches a similar size to the electrode tip contact area. So this is the effect of the process parameter welding time in resistance welding process. Next one is welding force. See, if the welding force is too low, explosion may occur immediately after starting the welding current because the contact resistance is too high. So if the welding force is too low, the explosion may occur immediately after starting the welding current because the contact resistance is too high. If the force is high, the contact area will be large. It will result in low current density and low contact resistance that will reduce the heat generation and size of the weld nugget. So welding force വളരെ കുറവാണെങ്കിൽ there is a chance that explosion will be occur because of high contact resistance. And if the welding force is very high, the contact area will be large. resulting low current density and low contact resistance that will reduce heat generation and size of weld nugget. അപ്പോൾ വെൽഡിംഗ് ഫോഴ്സ് കുറവാണെങ്കിൽ എക്സ്പ്ലോഷൻ ഉണ്ടാവും, വെൽഡിംഗ് ഫോഴ്സ് കൂടുതലാണെങ്കിൽ ഹീറ്റ് ജനറേഷൻ എന്തായിരിക്കും, കുറവായിരിക്കും. So in the case of projection welding, the welding force causes the collapse of projection in the workpiece. പ്രൊജക്ഷൻ വെൽഡിങ്ങിൻ്റെ കേസിലാണെങ്കിൽ വെൽഡിംഗ് ഫോഴ്സ് കൂടുതലാണെങ്കിൽ പ്രൊജക്ഷൻ എന്ത് സംഭവിക്കും, കൊളാപ്സ് ചെയ്യാനുള്ള സാധ്യത വളരെ കൂടുതലാണ്. ഓക്കെ, സോ ദിസ് ഈസ് ദ എഫക്റ്റ് ഓഫ് വെൽഡിംഗ് ഫോഴ്സ് in resistance welding process. So fourth one is contact resistance. See, when the welding force increase, the contact pressure increase, thereby the real contact area at the interface increase. That's the important point. When the welding force increase, the contact pressure increase. Welding force increase in അനുസരിച്ചിട്ട് contact pressure increase ചെയ്യും. Thereby the contact area at the interface also increase. Okay. Then the contact resistance at the interface decrease, which reduce the heat generation and size of the weld nugget. So contact resistance interface കുറഞ്ഞു കഴിഞ്ഞാൽ which reduce the heat generation and size of the weld nugget. So that's the effect of the contact resistance in resistance welding process. Fifth one is material properties. See, the material properties change with the temperature, which add to the dynamics of the resistance welding process. See, the resistivity of a material influence heat generation. The thermal conductivity and heat capacity influence the heat transfer. See, in a resistance welding process, the heat generation is dependent upon the resistivity of the material, and the heat transfer also depend upon thermal conductivity and heat generation, heat capacity. The hardness of the material also influence contact resistance. Harder the metal, that means higher yield stress will result in higher contact resistance. When the hardness of the material will be increasing, the contact resistance will also increase. And the last parameter is the geometry and dimension. The geometry of electrode in spot welding controls the current density and the resulting size of the weld nugget. So in the case of the spot welding process, the size of the weld nugget is affected by the geometry of the electrode which is used in the resistance welding process. So these are the main parameters which affect the resistance welding process. So first one, welding time, welding current, second one, welding time, third one, welding force, fourth one, contact resistance, fifth one, material properties, sixth one, geometry and dimensions. സോ നിങ്ങളിത് പഠിക്കുന്ന സമയത്ത് മെയിനായിട്ടുള്ള പോയിന്റ്സ് മാത്രം ഒന്ന് ഓർത്ത് വെച്ചാൽ മതി, കംപ്ലീറ്റ് ആയിട്ട് പഠിക്കണമെന്നില്ല. ഓരോ പാരാമീറ്റേഴ്സിനെയും മെയിനായിട്ടുള്ള എഫക്റ്റ് എന്താണ് റെസിസ്റ്റൻസ് വെൽഡിങ്ങിൽ, അത്രയും കാര്യങ്ങൾ മാത്രം എന്ത് ചെയ്താൽ മതി, ഓർത്ത് വെച്ചാൽ മതി. ഓക്കെ, സോ I am winding up this video. So in this video we have discussed about parameters in resistance welding process. There are 6 parameters and the effect of parameters in resistance welding process. Okay, thank you.